Okay, so now we're going to write exponential functions, and they're pretty easy to do. And we're going to talk about what they look like compared to like linear functions. So the first one, number one, is a linear function. So think about what happens when we have linear functions. The x value is increasing by 1s in this case, and my y values are increasing by 3. So that's my slope. So my slope is when the x values increase by 1, the y values increase by 3. And when x equals 0, y equals 2, and that's my b. So my equation is, I was going to write in 3, 2, so y equals 3x plus 2. Easy, and we've done that already. Okay, so when we look at exponential, my x values are increasing by 1 again, but my y values are increasing by times 3. So I have times 3 times 3, right? So everything's increasing times 3. So when the x value increases by 1, the y value, I guess, multiplies by 3. So this is the b, so it's kind of not the same as when we're doing linear, because this is my b value. This is the one that's going to get the x exponent. And when x equals 0, y equals 2, and that's my a. So a is 2, b is 3, y equals 2 times 3 to the x. But it's that easy to find the a and b values to put them into your function so that you can do an exponential. So let's go to number 3. Okay, my x values are increasing by 1, and my y values are decreasing by how much? 4? Okay, so it's like dividing by 4, or you could say times 1/4. And since we're usually using multiplying, we're going to do our times 1/4 because we're going to end up with a fraction. So we're dividing by 4. Okay. So it's an exponential. My b is 1/4. My a is 2. So my equation is y equals 2 times 1/4 to the x. Okay, next one. Increasing by 1. Decreasing by minus 2. Minus 2. Okay, minus 2. So this one is linear. And my equation is y equals negative 2x minus 3. Totally easy. Okay, let's do number 5. So my x values are still going up by 1. My y values are going up times 3. And 27 is my a. So it's a exponential. Y equals 27 times 3 to the x. And if I want to find what is y when x is 5, I have 27, times 3 to the 5th, which I'm not going to work that out. Use my calculator. And I get 6,561. And I'm going to put this into my calculator, and we'll do that in a second, and look for the y value of 531,441. Let's do number 6 real quick so we can look at the same time. Increasing by 1. Decreasing divided by 2, or multiplying times 1/2. Exponential function. My y value, my intercept is, 3. So y equals 3 times 1/2 to the x. So let's go over to my calculator, which is somewhere. And I'm going to go to my y equals. And I'm going to put in 27 times 3 to the x. And then I'm going to go to my second graph. And I'm looking for 531441. So I need to go down. There it is, 531441. So x equals 9. And then when x equals 5, I'm going to change that by hitting plus. No, I'm not. I'm going to go up to 8. And then I'm going to hit plus 1. So I get rid of those decimals. Okay, so if I go up to 5, there's 6,561. Okay, so those are my other two values for number 5. For number 6, I'm going to go back to my equation. And I'm going to put in 3 times 1/2 to the x. Then I'm going to go to my table. Oh, it's already in fractions for me. I like that. When x equals 9, it's 3 over 512. Or if I change that to a decimal, it's 0.01172. And then I'm looking for when y is 6,144. So I need to go where my numbers are getting bigger. So negative 11 is my x value. So let's go back to our notes. So when y equals that, x equals 9. When y equals 6,144, x equals negative 11. And y equals 0.01172, or 3 over 512. And either answer is fine. I find fractions to be easier, and I think I changed my calculator so it's always fractions, but either way is fine. It doesn't really matter at this point. Okay, so bacteria over time, I'm guessing it's going to be exponential. So my hours are increasing by 1s, and my bacteria is increasing times 2. Okay, so, and my A is 10. So my points are at 0, 10, 120, 240, 380. So here's my exponential curve, and it appears to be exponential. And how do I know? Because y is doubled every hour. Okay, it's increasing because it's going up. Okay, my equation is going to be y equals 10 times 2 to the x, because 10 is my y-intercept and it's going up by 2's. So how much bacteria would there be after half a day, and after how many hours would the bacteria be, blah, blah, blah. So I'm going to go back to my calculator. I'm going to go to my y equals. I'm going to clear that out. I'm going to put y equals 10 times 2 to the x. I'm going to go to my graph. I'm looking for 1/2 hours. So I'm going to go to 0. Okay, and I'm going to put in, I'm going to hit plus, which changes my table to 0.5. So now it should count by 0.5s. Okay, so 1.5 or 0.5 is half an hour, half a day. Oh man, half a day is going to be how many hours? 6, 12, 12 hours. Okay, I totally did that wrong. Let's go back to 1. Actually, let's change that to 2. Let's count by 2s. Okay, so half a day would be 12 hours. So for 12 hours, it's going to be 163,840 bacteria. And for 10,240 bacteria, that's just right here, that would be 10 hours. So back to my worksheet. Half a day, we're going to say is 12 hours. So y equals 163,840 bacteria. And for this bacteria, x would be 10 hours. Okay, so we are finding the information in the table, which is usually pretty easy to write the equation from that. And then you can put it in your calculator and use your second graph table to find the answers to the other questions. So there you go. They're quick again videos. Well, let's see if you, I don't know.